Good morning, ladies and gentlemen, and welcome to the Tech Talks on this Thursday morning. My name is Willem Klopper. I'll be your organizer for today. And with me, I have our presenter for today, Mr. Richard Wiederhold of Advanced Valves. Just before I hand over to Richard, just have a quick look at a quick video.
Occupational health and safety is not only enforced through legislation, but also critical for the sustainability of society, our economy, and the environment. TMP Magazine offers you convenient and easy access to information about occupational health and safety, especially for the skilled trades industry, right at your fingertips. Stay healthy and stay safe by staying informed. TMP Magazine, available on App Plumber or at www.themasterplumber.co.za.
Ladies and gentlemen, I am just about ready to hand over to our presenter. Richard, are you ready?
Morning, Willem. I am. There we go. Morning, listeners. Morning, plumbers. Thanks for listening in. Thanks, Willem, for the introduction. Today, we're going to be discussing Geysers Ancillary Products, which are the 4 items that make a geyser work, which is the drain cock, the PCV, vacuum breakers, and safety valve, also called the TMP valve. So I'm going to run through a couple of slides, starting with the PCV. And what we can see here is a cold water inlet, a cold water supply coming into the valve through the ball valve. It does a small bypass, goes down, and then goes through the cartridge of the valve to the geyser. The valve should always be installed above the geyser, and the overflow to the exterior of the building. The SANS specification for PCVs, safety valves, and vacuum breakers is called the SANS 198 for functional control valves. And in the specification, it states that the flow rate, minimum flow rate to be achieved through the valve on the control side is 40 liters a minute, and also on the relief side of the valve, it's also 40 liters a minute. So that's the first slide explained. And this is the second slide. So on average, you get about 600 kPa of water pressure. And when the water flows through the valve, the spring is set so that the valve will deliver about 330 kPa on a 400 kPa valve. So the difference between the relief and the control is about 70 kPa. And the reason for this is that when the geyser warms up, there's pushback towards the valve. As the water gets hotter inside the geyser, it gets bigger, and that needs to expand. So it gets pushed back towards the PCV, and it gets released out of the relief valve. And there's 70 kPa differential between 330 kPa and 400 kPa. And that allows the expansion to develop so that the valve doesn't always drip. That 70 kPa is like a buffer. So the valve won't drip for that 70 kPa until it gets to 400, and then it starts dripping. And then once you use your geyser again, or the taps, and take the pressure out of the valve, it'll return back to 330. And then as the heating cycle comes in, it'll build up and get to 400 again. So that's a continuous cycle. Then the third slide, well, this explains it even better. So let me explain. So from the geyser, you'll get 400 kPa pushing back because the water's now got bigger, and it'll push up towards the washer cup inside the relief valve. You can see where the 2 arrows, the green arrow and the red arrow, are meeting. That's where the seat is and the washer cup is. And that's where you get your expansion drops dripping out of your overflow. So I'll just quickly run through this again. There's 400 kPa of pressure in the spring in the relief valve, which is pushing down on a washer onto a seat. So when the expansion from the geyser reaches 400 kPa of pressure, it'll push back into the PCV, up, and lift up the washer cup, letting droplets out, expansion drops. In a 24-hour heating cycle, expansion will cause a drip of about 2 to 4 liters a day. So valves must leak. PCVs and valves, geyser valves must leak to release expansion. And acceptable is about 2 to 4 liters a day. That's the PCVs done. Let's go on to the safety valve. So that also falls under the 198 for functional control valves. Here we see the TP is closed, and it is a 400 kPa valve, which means, according to the SANS 198, we have to set it at 1.5 times the nominal working pressure. Therefore, we set it at 600 kPa plus or minus 10%. So it can go down to 540 or 660. That's the range that a TP valve can be set at. But we set them at 600. So if it's a 400 kPa, we set them at 600 kPa. A 600 kPa will be set at 1.5 times the nominal working pressure, which means 900 kPa. So that's how these TP valves are calibrated for pressure. And then we will see the temperature side of it. So, sorry, the still pressure. So there's the geyser pressure. When it gets to, on a 400 kPa, when it gets to 600 kPa, the washer will move up away from the seat, and you'll get water droplets going out the overflow to the exterior. The overflow pipe must always be in 22 mils, and it must be piped to the exterior of the building, and never with a 90-degree bend, or the maximum you can go is a 45-degree bend. So that's the pressure side of the TP explained. And now we'll go on to the temperature side. Here we can see heat from the geyser on the probe. There you see the white probe. So the heat of the geyser, when it's warmed up past, let's say the thermostat isn't working, it's failed. And now the geyser is starting to get up into the 90s, the temperature of the water. The probe, according to the SANS 198 for functional control valves, must open between 93 and 98 degrees centigrade. So what happens is that probe senses the water at that temperature, and the wax inside, when it changes state, expands by 10%. So what happens is there's a hard wax inside this probe, and when it changes state between 93 and 98 degrees, it turns into a liquid, and it expands, increases its volume by 10%, and expands and drives the pin up onto the washer cup, and that will release hot water, and then therefore cold water comes through the PCV and enters the geyser, cooling the water down inside the geyser. Because now remember, the element is on continuously, so the geyser is going to get hot and cold, and that's why you'll sometimes your client or your customer might phone you and say that sometimes they've got this hot water running off the roof and it goes away and then it comes back. So this is a safety valve busy doing its job. So when it gets between 93 and 98, senses the temperature, releases out hot water. When that hot water comes out of the overflow pipe, there's a loss of pressure inside the geyser, and the control valve senses that and lets more cold water in. So it actually keeps it in a fairly safe condition until the safety valve can be replaced, and the thermostat obviously also replaced at the same time. So yeah, sometimes TPs get dirt in them during this process. They can be opened and cleaned, but yeah, often you got to replace them because they get damaged. So that's your call. Let's move on to vacuum breakers. So I'm going to discuss 3 types of uses for a vacuum breaker. The first one is to reduce hydraulic shock. So as you'll see inside our vacuum breaker, there's a double seal. You'll see there's 2 springs. And what this does is we have a primary seal, the green one at the bottom, and a secondary seal, which is the yellow one at the top. And so we've always got, our vacuum breakers have always got a double seal, so they're very reliable. But moving along, there's an air gap when you pipe in the vacuum breakers, and they should be 300 millimeters above the geyser. And when these are piped in, you'll pipe them in and fill the water pressure, put water pressure, and you'll see here, the water fills up into the pipe a little bit, okay, and the rest is an air gap. So when you use the water, when you use the taps, the water will drop inside the pipe, and when you close the tap, it'll bounce up, it'll push up here. So this is compressed air. So it's like a shock absorber, and that'll protect the geyser from hydraulic pressures and shock. So that's one very good reason to use geysers. I mean, vacuum breakers on geysers. It does protect them and give them a longer life. Another reason to use vacuum breaker is when you drain a geyser, you can get an airlock. So what happens is the weight of the water, as you drain it out the drain cock, it'll want to come out the drain cock. But because if you don't have a vacuum breaker, it'll create an airlock and you won't get the water out of the geyser. So these vacuum breakers, according to the SANS 198, must open between 0 kPa and -3 kPa. So it's not a lot of suction that'll open a vacuum breaker to let air in and to let water out the drain cock, so you can drain the geyser and work on the element of the thermostat. And here's the third reason to use vacuum breakers. If you're working on a multi-story building, during the repair or replacement of a geyser, the weight of the water, let's say in a 50 millimeter pipe up here, is quite substantial after over 5 floors. So the weight down here could be like 200-300 kilograms. So if you don't have a vacuum breaker up here, like this, so here's a vacuum breaker working, letting air in. So then air will come in and water will come out the bottom of the pipe. If you don't, this is the example, if you don't, that weight of the water can suck and crumple the geyser and damage the geyser. So those are 3 very good reasons why we should be using vacuum breakers. And then we'll move on to the drain cock. So our advanced valves drain cock is as a double seal, a primary seal, and a secondary O-ring. So there's a washer and a seat, and here's an O-ring, so there's a double seal. And so this is water, cold supply, being let into the geyser because it's in its open position. In its closed position. It's in its closed position, letting water into the geyser. We go to the second slide, you will see here that the geyser is now being drained. So warm water can bypass the plug. The plug is screwed out to drain the geyser, and warm water can drain out of the tailpiece of the drain cock. That's obviously, of course, you've got to switch off your pressure coming in. So you'd use your lever angle valve or whatever else you've got going on. Stopcock, just switch off the main supply, open the plug, and water will come out of the drain cock. So I see there's a mistake on the slide. It should be the SANS 1808 part 53. That is for drain cocks. And you'll see it here, SANS 1808 part 53. The minimum flow rate that a drain cock should allow water out is 10 liters a minute. So you need to, otherwise it'll take all day. So we need 10 liters a minute of flow of water to come out of the drain cock. That's the minimum that's required. So yeah, Willem, that's the presentation for this morning.
Thanks for that, Richard. It was very interesting. As a layperson, I'm not a plumber. I learn quite a lot from these technical webinars. Richard, it doesn't seem as if we have any questions. So I think what we can do is just to allow the 1 or 2 minutes for the attendees. I'd like to urge the attendees, if they've got any questions for our presenter, Richard Wiederhold from Advanced Valves, please type them into your questions and answer session. So Richard, if you don't mind to just give it about 1 or 2 minutes. I see that we still have quite a few minutes left of this presentation. There is one question that just came in. It comes from Emil, and Emil asks whether we can please put up the diagram of the PRV again. Yes. So Richard, if you don't mind, just to display that diagram of the PRV again, please.
100%. Let me go to it. Let's go to the first one. There we go.
Emil, did you have a specific question regarding the PRV, or did you just want to see the diagram again? You're welcome to type your question into Are you there, Emil? You could just, if you had a specific question regarding the PRV. I see Alan Lee just came up with another question here. Is the expansion rate 2 to 4 liters per heating cycle?
Depends on the size of the geyser. So the bigger the 200-liter geyser, there's going to be more water in there, and there's going to be way more water to heat up. So on a 200, you're going to get more. On a 50-liter, you'll get less because there's less water in a 50-liter. So there's quite a big difference. That's an average. That's sort of people bandy. There is a calculation. It's quite a complicated one, but we just like to say 2 to 4 liters a day. That's on average, So you're probably on a 50-liter, you might get 1. On a 200, you might get 3. So we just work, maybe more. It depends how many times you empty the geyser and reheat it. So there's lots of factors that can determine how much a valve will expand in a 24-hour cycle. We just use 2 to 4 liters. Seems to be fair.
Richard, it seems as if this is going to be a like an interactive session. I see that a couple of other questions have come in. Emil, who asked you to display the PRV again, the diagram of it, said thank you. He just wanted to see the pic to explain how they work. So he thanks you for displaying it again. Then I see Vusikaya Mabena has asked another question and said he have heard some plumbers saying that vacuum breakers should be fixed on the wall with holder bats. Richard, what have you got to say to that?
No, not according to the SANS 10254, because the vacuum breaker would often be directly in the center of the geyser. So it just has to rise up 300 mils above the geyser. And I think there's also now on the hot water side, it has to be 700 mils past the overhang. So it must, how can I say it? It must be, what's the right word to use here? It must be 700 mils away from the geyser on the hot water side and 300 mils above. That's to stop the heat getting into the vacuum breaker and shortening its life.
I see, Richard. Thank you for that answer. There is another question that came in from Pascal Naidu. Pascal asks, once the geyser that is under warranty, can these valves be used?
Okay, that's a good question. So 100%. So the PCV, okay, let me go back. A geyser hot water cylinder, when it's submitted to the SABS, it will be accompanied by a drain cock and a safety valve. And the SANS 151 says that that drain cock and that TP valve must be used in the testing of that geyser. So for the 5 years of that geyser, that brand of TP valve and drain cock should be used with that geyser. After 5 years, you can use anything. So some geyser manufacturers are saying that the warranty will fall away if you change to another brand of drain cock or safety valve. But a vacuum breaker and a PCV any vacuum breaker or any PCV can be used on any geyser. They are different products. They don't work better together. Valves are all within 5% of each other. The specification for the 198 for functional control valves, the SANS 198, is very strict, and the flow rates and set points are extremely tight. They all have to do, the PCVs all have to do 250,000 cycles to gain the mark, and that's on the relief and the control. So it goes through rigorous testing. And vacuum breakers are also allowed to be used on any geyser. So you can choose your brand. According to the Consumer Protection Act, you may choose your brand. So if you want to put, I'm not going to name any brands of geysers, but if you want to put advanced valves on any SABS approved geyser or SANS 151 approved geyser, you may. It's 100% legal.
Richard, just from my side again, quickly, just for clarity, I heard you say that the valves don't work well together. Did I hear correct?
Yeah, no. So they do. So let me explain that. So the valves will work very well with any geyser because they're all within 5% of each other, the valves. So they will work on any geyser. They work perfectly on any geyser. It makes very little difference. So you can choose your brand. There has been murmurings in the market whereby some people are saying their geysers work better with a certain kind of valve. That's just hearsay. I don't agree with that. So you can use any valve on any geyser legally. This is what we're talking about, the legal aspect. As long as it's compliant to the SANS 198. So if the vacuum breaker and the PCV are SANS 198 compliant, they may be used. And when I say compliant, it doesn't have to be SABS. It can be SAPCS. It can be Test Africa. It can be another certification body. So long as it complies to the SANS 198, you may use it anywhere.
And of course, if the geyser complies to SANS 151.
Yes, that too. So they must both be compliant.
Richard, Emil has sent us another, it's actually not as much a question as what it is important statement. He said, important to check that the pressure rating on the PRV and TP is not higher than that of the geyser.
Okay, agreed. So if we've got a 400 kPa geyser, then you need to use a 400 kPa safety valve. And the same with the pressure control valve. So match like for like. You could put 400 kPa PCVs and safety valves on a 600 kPa rated geyser, but you can't go the other way around. You can't go and put 600 kPa PCVs and PCVs and safety valves onto a 400 kPa geyser.
Thanks for that answer, Richard. I see that Michael Sionani has also typed a question in here. He said, is it true that the PCV protect the geyser from bursting only or to keep the balance pressure of the whole house? Well,
that's a good question. It's a bit of both, actually. So let me answer the first one. The PCV reduces the municipal pressure down to, in the 400 kPa valve, it'll reduce it down to about 330 kPa, and in the 600 about 600 kPa version about 480 to 500. So it does protect the geyser from overpressurization from the council side. So it's like an electricity. You get electricity sparks, you can also get water sparks. And so the PCB is there to protect the geyser. And also when the geyser warms up on expansion, the pressure rises, and the relief valve will help to release that pressure out of the relief valve. And the second part of his question.
Let me just have a look at that question again quickly. I said, is it true that the PC valve protects the geyser from bursting only, or is it also to keep the balance pressure of the entire building, the entire house?
Yes, so that's another function of it. So after the outlet of the PCV, on the outlet of the PCV, you can then tee off to your cold water taps, and the other line can go to the geyser. Because after the geyser, you'll be sending hot water to where you've teed off your cold supply, and they should be meeting up in, let's say, your tap, 330 kPa on the cold and 330 kPa on the warm or hot, and that will give you a balanced pressure. But you have to tee off after the outlet of the PCV, which is over here. You'd put a T in over here, and then this supply would be your cold water supply, and that would be 330, and this would go to your geyser at 330, and then that meets at your tap, let's say up here, cold 330 and hot 330, and then you get your balanced pressure at your tap.
Thanks for that answer, Richard. It seems as if we have run out of time for this morning's webinar. It also doesn't seem as if there are any other questions. I would like to urge the attendees to contact Advanced Valves if they have any further questions, specifically regarding the Advanced Valves itself. Richard, thank you for your presentation and the valuable information that you've shared with us. I think it carries as much value to the attendees as it carries to me. Is there any last words that you would like to add to our attendees just before we end the session off?
Yes, thanks, Willem. Firstly, thanks very much for listening in, plumbers, today. Great job you're doing out there. Keep your standards up. And remember, try and support proudly South African products and South African companies. We are South African after all, and we need to look after each other. Thanks so much again, guys. Have a great day.
Ladies and gentlemen, we're going to say goodbye, and I'm going to end off this session. Have a great day and a great weekend.